Okay, this is a chemistry higher level question, 2012, question 10c on stoichiometry. And we're told here that a bracelet originally made of pure silver became tarnished over time with black silver sulfide, this Ag2s, forming on the surface. The bracelet was cleaned by converting the silver sulfide back to metallic silver using aluminium in the following reaction. And the mass of the bracelet decreased by 0.0096 grams in the cleaning process. The first part of this question is asking us what substance was oxidized in this cleaning process. Now, the first part of this question isn't actually a stoichiometry part. This is an oxidation and reduction part, but we're going to answer it anyway, and then from there on we're going to be talking about stoichiometry. So, what substance was oxidized in this cleaning process? Well, to answer this question, we need to know that oxidation is the loss of electrons. So we have to know which of these substances actually lost electrons. Was it the silver, the sulfur, or the aluminium? Now, this is actually a difficult question to answer using oxidation numbers, because we don't actually have specific rules for silver, sulfur, or aluminium for assigning oxidation numbers. So we need to use a different tactic for answering this question. And to answer this question, we're actually going to remember back to our bonding and what happens to different elements when they bond. What type of ion do they form? So this is a periodic table showing the charges on atoms that form after they form a bond. So we can see some form no ion. Okay, so some of these form absolutely no ion. In group 1, we can see that they form a +1 charge. In group 2, we've got a 2+ charge. But it's not the same for group 3 and group 4. We can see we've got the no ions there. But we can see in group 3 we've also got aluminium. And for aluminium, in a bond, it forms a 3+ charge. And in order for it to form a 3+ charge, it must have lost 3 electrons. So this is telling us what we need to know now. So oxidation is the loss of electrons. And which substance was oxidized? Well, the aluminium went from having all of its electrons to forming a bond where it's gone to a 3+ ion. So aluminium has formed a bond, and therefore it must be gone to a 3+ ion. So therefore aluminium has lost electrons, so aluminium has been oxidized. So aluminium has been oxidized. Okay, so now onto our stoichiometry part of this question. How many moles of sulfur were removed from the bracelet when the silver sulfide, this Ag2s, was converted to aluminium sulfide, the Al2s3? So, how many moles of sulfur were removed? So we can see we've got our balanced chemical equation here. And we've got our silver sulfide, and the aluminium comes along and takes off the sulfur from the silver to form this Al2s3. Now this is actually a little bit difficult to visualize just looking at this balanced chemical equation. So what I've got here is I've drawn out the atoms of the silver. So we've got all our silver atoms here, and this is our silver bracelet. And we can see over time some sulfur atoms have joined onto our silver bracelet, and this is the tarnished substance, the Ag2s. Ag2s, 2 silver atoms and 1 sulfur. So we've got this set up. Our bracelet is tarnished because we've got our Ag2s stuck onto it, and now we want to clean our bracelet. So what's happening here is we're going to remove the sulfur atoms by using aluminium. So what we've got here, we've got our silver bracelet back again, and our aluminium has bound the sulfur atoms, and this is our Al2S3. 2 aluminium atoms, 3 sulfur atoms. So we can see that the loss in mass from the bracelet after cleaning it is simply because we have lost those sulfur atoms. So we have to calculate how many moles of sulfur were removed. Well, we're told that 0.0096 grams was lost during the cleaning process, and that mass is due to the loss of the sulfur atoms. Now we need to simply now convert from grams of sulfur to moles of sulfur. Okay, so we need to go to our periodic table, and on that we'll find our relative atomic mass of sulfur, and we'll see that that is 32 grams per mole. And what this is telling us is that 32 grams of sulfur is equal to 1 mole of sulfur. Now, we're not interested in 32 grams, we're interested in 0.096 grams. So we're going to divide both sides by 32 to find what 1 gram would equal. So 1 divided by 32 moles. And then we're going to multiply it by our 0.0096 grams. So 0.0096 grams is equal to 1 over 32 multiplied by 0.0096, and that is equal to 0.003 moles of sulfur. And that's the answer to that second part of that question. How many moles of sulfur were removed from the bracelet? Now part 3 is asking us what mass of aluminium was used in the reaction. So what mass of aluminium was used in the reaction? So we can look at our balanced chemical equation here, and we can see, well, we've removed our sulfur atoms and we've used our aluminium to do that. And here we can see that we used 2 aluminium atoms for every 3 sulfur atoms. And this can be a little bit difficult to visualize, so I'm going to go back to this. So we had our sulfur bound onto 2 silver atoms, and then the aluminium came along and bound that sulfur to the aluminium. And it took 2 aluminium atoms to remove 3 sulfur atoms. And that's a really important relationship there. Okay, so if we've got our sulfur here and our aluminium here, we know that we had 3 atoms of sulfur for every 2 atoms of aluminium. Well, we could go further with this and we could say that, well, if we had 3 moles of sulfur, we would have 2 moles of aluminium. 2 moles of aluminium to remove 3 moles of sulfur. Well, from the last part we know that we had 0.003 moles of sulfur, and using the same ratio, this is going to imply that to remove that many moles of sulfur, we would need 0.002 moles of aluminium. So now what we have is we have the number of moles of aluminium, but the question asks us what mass of aluminium. So we have to convert from moles to grams, and to do that we need to go to our periodic table and find the relative atomic mass of aluminium, and that is 27 grams per mole. So this is telling us that 1 mole is equal to 27 grams of aluminium. Well, we've got 0.002 moles, so we're going to multiply both sides by 0.002 to find out how many grams will be in this number of moles. So 0.002 is equal to 27 times 0.002, and that is equal to 0.0054 grams of aluminium. And that there is the answer to that part of the question. Okay, now for the last part. What would the loss in mass of the tarnished bracelet have been if it had been cleaned by the alternative method of removing all of the silver sulfide by polishing? Okay. So in this case, instead of just removing our sulfur atoms, we're going to remove the silver sulfide. So we had a loss in mass due to the loss of the sulfur atoms, but now each sulfur atom that we're removing is going to take with it 2 silver atoms. So we're actually going to be losing a lot of silver from the bracelet here. Okay, so what we need to be able to recognize from that is for each sulfur atom removed, we also are now going to be removing 2 silver atoms. So that's this here. Now we're removing 2 silver atoms when we're taking away that sulfur atom. So we've got our sulfur here, and we've got our silver sulfide. So for every 1 atom of sulfur that we remove, we're taking with it 2 silver atoms, but also 1 silver sulfide molecule. So we're going to be taking 1. So for every 1 atom of sulfur, we're going to be taking 1 molecule of silver sulfide. So we know the number of moles of sulfur that we had. We had 0.003 moles, and using the same ratio, this means that we're also going to be removing 0.003 moles of our silver sulfide. So now we have the number of moles of silver sulfide. We need to convert from moles of silver sulfide to grams of silver sulfide. So to do that, we need to make up our relative molecular mass of silver sulfide, which is Ag2S. So we go to our periodic table, we find the relative atomic weight of silver to be 108 grams per mole, and sulfur to be 32 grams per mole. Now we've got 2 silver atoms, so now we're going to have to multiply this by 2. And that's going to equal 216 grams per mole plus our 32 grams per mole, and this is going to equal 248 grams per mole. So now, this is telling us that 1 mole of our silver sulfide is equal to 248 grams. Well, if we've got 0.003 moles, this would give us 248 multiplied by 0.003, and that is going to equal 0.0744 grams of our silver sulfide. And that's the answer to that last part of that question there. So what would the loss in mass be of the charged bracelet if it had been cleaned by the alternative method of removing all of the silver sulfide by polishing? And just to check our work here, when we were only removing the sulfur atoms, we removed 0.0096 grams in the cleaning process. But now we're removing much more mass. Now we're removing 0.0744 grams. So this makes sense. We're taking with it an extra 2 atoms of silver.